From Developer to Architect, the ServiceNow Mastery Series. Hello and welcome to From Developer to Architect, the ServiceNow Mastery Series. I'm so excited to have you here, because this series is created with one purpose in mind: to help you, the ServiceNow developer, grow into a confident and capable architect. For many of us, starting out as a developer means focusing on code, fixing bugs, and delivering small features. But the journey to becoming an architect is very different. It's not just about solving individual problems. It's about designing solutions, scaling systems, and aligning technology with business outcomes. And that shift requires a new mindset, new skills, and a deeper understanding of how ServiceNow really works at scale. That's exactly what this series is all about. Over the course of these episodes, I'll walk you step by step through the critical knowledge areas every aspiring architect must master. From performance optimization to multi-instance architectures, from automation pipelines to real-world security solutions, we'll cover it all. The goal is to bridge the gap between coding and architecture, between being an implementer and being a strategic problem solver. And here's the best part: this isn't just theory. Everything I'll share is based on real-world experience, practical scenarios, and lessons learned from working with global clients and large-scale ServiceNow implementations. So whether you're just starting to think about the architect path or you're already on your way, this series will give you practical insights you can apply immediately. Now, let me take a moment to introduce myself. My name is Gugin Jolly, and I am the founder of the Naugarukul ServiceNow Learners Club. Our vision at Naugarukul is simple but powerful: to grow together by learning 1% every day. I am also a ServiceNow Certified Technical Architect, with over 8 years of experience in the ecosystem. Over the years, I've worked with clients across telecom, FMCG, and financial domains, helping them design and deliver enterprise-grade ServiceNow solutions. But more than my certifications or professional work, what drives me is the passion for sharing knowledge and building communities where learners can thrive. That's why I created this series, to give back to the community that has given me so much. Now, let's talk about what's coming up in this series. We'll begin with building for performance, exploring instance architecture reviews, request handling, session management, working with large datasets, and asynchronous processing. Then we'll move into the second performance chapter, where we'll look at inbound integrations, batched REST requests, Java heap space, and caching strategies. From there, we'll dive into multi-instance architecture, covering implementation models, real business case examples, and topology principles. We'll also explore CI/CD in the real world, including source control, application repositories, automation, and deployment strategies. And that's just the start. Later episodes will cover the ServiceNow Vault Suite, real-world security challenges, Stream Connect with Apache Kafka, predictive and task intelligence, Now Assist for creator workflows, and even advanced topics like handling 200+ developers in CI/CD, deep dives into Gen AI.
Okay, so we'll start off with an overview of what a standard instance looks like. So, this is the sort of general picture. We have a client, typically that's behind a local firewall. It gets the DNS entry for the ServiceNow instance, that points it at our primary firewall. Behind that then we have an F5 or Nginx load balancer. They're almost all now Nginx based. We've been on a program over the past year to change those. So you hit the load balancer, and that then puts you to one of your application nodes. Those application nodes eventually route back to the primary database. In a production instance, we've also got a standby data center as part of our advanced high availability cluster. So we have the notion of a primary data center and a standby data center. Standby data center should be a mirror of the primary data center. It's just worth noting that the standby nodes are all up and running and connected to the primary database. We do that because we don't want to discover an issue when you need to failover. So, if there are any issues with the standby side, our monitoring can pick it up and sort of carry out corrective actions because everything should be on all the time. And then the primary database is replicated currently using MariaDB replication. That replicates to the standby database, so everything is held in sync. So, if there are any issues with the standby side, our monitoring can pick it up and sort of carry out corrective actions because everything should be on all the time. And then the primary database is replicated currently using MariaDB replication. That replicates to the standby database, so everything is held in sync. So, what happens when you failover? The first thing that happens is the nodes disconnect from the database. We're actually modifying this slightly this year to try and improve the failover performance. But essentially, what happens is the nodes acquiesced. They disconnect from the database. And what then happens is the direction of replication is reversed. It's not strictly true. What actually happens is we toggle the read-only flag. So, we've got circular replication set up. So, the standby is replicated from the primary, but equally the primary is replicated from the standby. We don't actually touch that. What does happen is we set the read-only flag to true on the primary, and we set it to false on the standby. And that basically makes the standby writable. What then happens is the application nodes connect to what was the standby database. And eventually, DNS is updated. And that typically takes anything up to 5 minutes to actually filter through. But it doesn't matter during that period because our data center interconnects are pretty chunky. So, even though you might be going to the load balance from the primary data center, we can handle the load. And so, there's no adverse impact to you being still connected to what was the primary data center. And that's it. Then you failed over. It typically is for maintenance. But if there are any issues, then we would fix the now standby data center. And off you go. So, how does the load balancing work? This is quite often a bone of contention with customers because our load balancing is rather simplistic. It actually works in our favor because it prevents issues on a single node from spreading to other nodes because when you have a session on a node, you're basically stuck to that node. And if you trigger something that impacts that node, you're still going to remain stuck to that node. We're changing that slightly this year again to take more notice of the current load of a particular node. So, rather than a straightforward round robin, what will happen now is the busier nodes will be used less until such a point that the load balances out across them all. But I think that's being rolled out later this year. But essentially, what happens when you hit the load balancer is it looks at the cookies that have been passed with that initial request. If it finds a valid session cookie and I think we call it a big IP cookie, if it finds those, it means you've already got a session established. And within those cookies will be the information telling the load balancer which node to connect you to. So, in this case, it's putting you through to the LMDev03 node because it's found the cookie that specifies that particular node. More advanced customers sometimes get into manipulating this, but typically this all takes place under the hood and nobody ever notices. Hey, John. Sorry, quickly. We've got Sergio with a question. Sure. Thank you. It's from the previous slide. I don't think you need to go back to it. Does the standby and production basically stay that way after you fix whatever was wrong with what now is the standby? Or do you flip it back over at some point back to the data centers? No. What typically happens, we have a quarterly patching program. So, typically we require transfer at least once a quarter. There may be sort of more urgent maintenance issues that occur and force a failover, but we have no preference which data center customers are connected to. And we got a great lens to ensure there's absolutely no drawback to being connected to one data center over another. We had issues in Southeast Asia a couple of years ago where sort of the difference between Seoul and Singapore was impacting some customers, but that should never happen. So, even though some customers will insist that, no, I really want to be connected to this data center, we try and discourage that and treat them all the same. So, no, once you failover, you'll stay on that side and then something will happen at some point that will force us to failover again and you go back to the other side. There should be no difference. And ideally, customers won't notice and they won't have a preference. But obviously, sometimes something can happen that makes a customer think, oh, no, that data center performs better than the other one. So, I want to be on that. But we try and discourage that. Thank you. Yeah, so load balancing, you have a session cookie and that then sticks you to that particular node. It's worth noting that this is a representation of a typical shared infrastructure instance. That's our standard offering. Customers can elect for dedicated hardware, in which case we will have a series of servers, sometimes even an entire rack, dedicated to a particular customer. But typically that's not used that often. Okay, so, what's the advantages of this kind of multi-instance architecture? I was a bit disappointed when I came to ServiceNow because I'd seen all the sort of marketing stuff and we tout this as if you've got separate hardware. It's actually shared. But the difference is that we spin up separate JVM instances and separate database instances for each customer. So, the database itself is entirely separate from the customer sitting next to it, even though the physical server can be shared. So, typically what we see here is we've got one application server here with sort of, well, at least 2 nodes on it. We've got another application server here, which has node 4 of this LM-dev instance, and then in the same rack, then we'll have a database server. And you can see here you've got the LM-dev database server. They're all protected by routing tables that ensure that only your application servers can talk to your database, all that kind of thing. And we'll come to some of the advantages of this now. So, no co-location of data. It's the same physical server, although they are separated by the database entities. It prevents any spillover from a sort of single instance on a database server or a single instance on a Java virtual machine from impacting the others. But you still have to bear in mind that it is the same single instance of the operating system and single physical server. Availability and scalability. Yes, we can scale out by simply adding application nodes, and we can scale up with the database server by basically making it bigger, allocating more of that database server to the database instance. All of this is transparent to the customer. We typically try not to discuss this kind of stuff with customers, because ultimately what happens is as soon as a customer sort of gets hold of the idea that you can upsize their database, then as soon as they hit a performance problem, they're like, I want my database upsized. And we're like, well, that's not the problem. You need to fix your query. So, but again, because this is the advanced architecture, we were sort of peeling back the covers a bit. John, we've got a question from Leo. So, John, can you elaborate more on the further enhanced via encryption options, please? Because I want to understand, like, how exactly will the encryptions for C, because when you say database is one and there's going to be a racking sector, right? So when you do an encryption, how exactly is it going to be on the application layer you were talking about, or is it going to be the database encryptions? There's typically 2 levels of encryption we offer. I'm not that up to speed on it. It's been a while since I looked at it. But basically, we have database level encryption, and that's typically what you see on a shared architecture instance. We can also have entire disk encryption, but that's only for obvious reasons. That's only available for dedicated customers. And the entire database server is encrypted, and we use some high-performance encrypted SSDs for that. So that doesn't impact any of the database's performance, is it? Because some of the disks will be fragmented and encrypted, but whereas there are certain other disks, which is not. So have you seen any kind of performance issues because of that on the nodes or anything as such? Not on the full disk encryption ones, because we use some very expensive hardware there because the customer has to pay for it. And so we can pass those on. And again, even at the database encryption level, we've got some pretty good hardware to make sure that that's not impacting. And it's more and more standard now anyway. Okay, because why I asked that question is because we had one of the clients where there was a lot of performance issues coming in because they had almost like, let's say, 1 trillion of data. That's almost like out of 20 terabytes. They have already used up 16 terabytes of data and space. And the information that came in was from ServiceNow. So they suggested that they may have to go into a dedicated database because things are running out. The nodes are completely dead. And this is the same thing that they spoke about. They were like, in the database, there are application-level encryptions, which is happening and due to which the slowness of performance is happening. So that's the reason I want to check. How exactly is that coming? Yeah, I mean, typically with an encrypted database, there's encrypting jobs that have to run. And typically after an upgrade, we have these mass encryption jobs and they can take a long time and be very impactful because I mean, the main culprit is things like sysattachment, where it has to go off and re-encrypt it with a new set of keys. That can take a long time. You can ameliorate that by moving to dedicated encrypted hardware, in which case the application nodes don't even know it's encrypted. It's just talking to the disk and it's transparent. I suspect that's what the discussion was there. But normally, I mean, we work with some pretty big instances. I've just upgraded a 35 terabyte instance, which I encourage you not to get there, please, because it causes all sorts of problems. But they upgraded and the encryption jobs took, I think, about 36 hours. So it does take time, but they're pretty performance tuned and they're low impact. But I suspect that's what they were referring to in that case. I think you're talking about the same thing. Cool. Okay, so shared architecture, we've got multiple application nodes from different customers sharing the same physical hardware. And likewise with the database. Even though we've got this ability to sort of lose application nodes and replace application nodes, we've still always got that single point of failure, which is the primary database. So in the event of a catastrophic failure on either that database server, obviously we've got rated disks. We've got everything that can be made fault-tolerant is fault-tolerant. But at the end of the day, the primary database is a single point of failure. If that happens, that's when our heart kicks in and you'd be transferred. If we can't immediately recover the primary side, sometimes we have occasional database crashes. They recover immediately. And, perhaps you're looking at a couple of minutes downtime. If it's more serious than that, what will happen is our monitoring will detect an issue with the primary side and it will automatically fail over. Typically, you're looking at sort of 5 to 10 minutes downtime whilst that takes place. The other potential drawback of this kind of architecture is noisy neighbor. So you can see that that's the application nodes in green all belong to the same instance. But if one of these other instances, and it could be an application node, it could be a database server. If somebody does something on that severely impacts the performance of the hardware itself, that can impact you as a customer. So just be aware that we usually pick it up before the customer does. But it can occur. John, okay, question from Abhinav. You just mentioned that we do not promote load testing on production hardware and impact multiple other organizations. Now, if you're doing load testing with real-life production volumes, shouldn't we be allowed to do that in a sub-production instance? We have a commercial offering for that. I know, but that is my confusion around that commercial offering is on a setup that is separate from all the other infrastructure, which doesn't give you the true value of your test because you're on shared versus dedicated infrastructure. And because production-based, you should be allowed. I guess the problem is if you really took a sort of a stress test to the extreme, I can't imagine it ever happening, but you could potentially, max out the network. You could max out the iOS subsystem of a database server, and that's going to impact everything in that rack or everything on that server. And for that reason, we don't allow it now. Yes, I totally agree. It's not really a like-for-like test, but typically when we're talking about these customers that are willing to look at the sort of cost of load testing, then they almost buy by the nature of their size, they're pretty much dedicated hardware, even if they're not paying for it, because once we get up over a certain size, we reserve that database server for that customer because basically we can't fit anything else on there anyway. So, yeah, it's not a perfect like-for-like, but it's a near enough approximation. But, yeah, that's a valid point. But just to avoid impacting other customers, we discourage it. So for this part, we're going to go and continue talking about the instance architecture. We're going to try to cover some basic parts about the application nodes. So as in every IT bit, you would have something that would carry your traffic or something that you would start working with. So in ServiceNow, we do have what we call the application nodes. And this is one of the main building blocks of our instance. It consists of 3 main parts, or what are the 3 main parts for any application node? It's the Java server, which is what you call Glide. We have the server container and we have the Orbit which would wire the Glide to the Tomcat server, the server container. So that would be the main 3 building blocks for our application nodes. So each and every application node in a normal architecture, what you will find is it has a pool of threads. And what are these threads? As you can see here on the right side, these are what will execute any kind of work. And what would be the work the instance can carry or the application nodes can carry? That would be a part that we will be covering later in the transaction processing part of this presentation. But mainly you have something which will carry your traffic to be processed, to be sent back to the database. And then you'll have a kind of output or something like that. Also, we have a JDBC driver which connects these application nodes to a pool of the database that would allow the interaction between the application nodes and the database to send any kind of traffic back. And depending on the size of your primary database, we have multiple sizes actually for each and every single instance. IT can support up to 37 application nodes per site. So in total, we have 74 nodes. Yes, we have big customers, big names, and they have that amount of application nodes. And sometimes even we see performance issues with that. So what would be the normal types of these nodes? We have multiple types that we can see for these nodes. First type would be the generic, which is the default type of these nodes. This kind of generic will process, I would say, nearly anything, any kind of user traffic, any kind of integration transactions, any kind of scheduled jobs. Or you can have a bit of more specified. It could be the UI, which will only process user or integration transactions. And if you have a specific job that you've pinned to that node, so you can go for a job and you can specify which node this can run on, and we'll be talking about that later. And also you can have a worker node. So worker nodes, what will happen for these? They would be only dedicated for processing scheduled jobs. So if you are a big customer and you have loads and loads of jobs that would run and it may impact the other traffic, which might run on the instance or the application nodes, we can dedicate some nodes to go and handle these scheduled jobs. Also, you can pin some integrations as well. So if you do have an integration, you can, whenever you're configuring this integration, you can specify exactly which node you need this to run on. So by default, if there is a new instance, if you're a customer for ServiceNow, we're spinning a new instance for you. What will happen is you'll have the generic nodes. UI and worker nodes, these are only deployed in very specific circumstances. And it needs a lot of discretion from our side. Loads and loads of decision needs to be taken in that part. And loads of teams actually need to be involved in taking this decision. So normally, if you have an instance, it will execute scheduled jobs. If it caused some memory contention, for example, as I was saying, you're a very, very heavy job running customer. So you might need these worker nodes for them to be dedicated to take the load out of the other nodes and get some like breathing space for the other user traffic or API integration traffic to run on the rest of the nodes. So as I was saying, whenever there is a job, it executes. The end users might get impacted. You know, if it's very, very heavy, the performance overall will be degraded. These jobs, like we've checked, we are engaged or maybe our colleagues in the support or something. We take a look, we try to tune as much as we can, but we can still see issues. They are untunable, I would say. And like, you know, we've reached a dead end or something. At that time, we'll be going into, okay, let's provision a UI and a worker node. So we'll specify the UI nodes. They will carry, as I was saying, the user integrations, the user or the API integration traffic, and we'll specify other nodes. We'll call them worker nodes. They will be totally isolated from this. So each and every type of traffic, it would run on the dedicated node at that time. How are we specifying that, or how can you check what would be the type of this node? So you can go to a table, which is called syscluster state table, or you can go to the stats.do. So first of all, if you type your instance name or the fully qualified domain name /stats.do, you can get which data center you are running on. As here in this screenshot, you can see, okay, I have this blah, blah, blah instance /stats.do. And from here, you can see you're running on the France data center. Then you would go to the syscluster state table, and you would type in the name of the data center and system ID in here, and you would be able to see the application node you are looking for. You'll be able to see the status, whether it's online or not. And you would see one of two things. It would be either any or specified. So any node which has any, this is a generic node, or this is, as I was saying in here, it's one of the default nodes. Or if there was any kind of specification done for you as a customer, you would see a word specified. Okay, why do I have something like that? Or what happens in here in order for us to see something like that? Or if you open your instance and check this and you find any or specified where this is coming from or what's happening in here. So our use of this UI and worker node is avoided, or we don't recommend this as the first thing to look into as from your site as a customer. This would increase loads and loads of administrative overhead on you. So you don't want to do any kind of configuration impact on your integrations. As I was saying, if you want, you can go for integration and you can specify where this needs to be running. This would add some administrative overhead. You need to go and do this manually. Or even if you script something like that, you need to spend time doing that. Also, this will reduce the resources for the overall instance. So imagine you have 20 nodes. These nodes are generic. They are shared by everyone and anything on the instance. You can have users. They can log into any of the nodes. They can run their work on it. Or if you have API integrations, they can connect to any of the nodes and they can fetch information or build reports or do any kind of things in the background. Or you have your scheduler jobs that can run, that can do any kind of processing in the back end. If you go with the UI and worker, or if we decided that you need to go with the UI and worker split, what will happen is we will not be doubling the count. So we will not have 40 nodes, or you will not have by 2 nodes. What will happen is the number of the nodes will stay the same, but they will be split. So you have now lost like 50% of whatever you have, so the users, they lost now nearly 50%. And the workers, unless and until you pin something, they lost the other 50% of the available resources that you can give them.
I hope this session gave you valuable insights that will help you grow not just as a developer, but as a future architect. Remember, the path to becoming a strong ServiceNow architect is about consistency, curiosity, and building the right mindset. Don't forget to subscribe to the channel, hit the like button, and share this with your peers in the ServiceNow community so together we can keep learning and growing. And as always, think big, build smart, architect better. See you in the next episode.